Universities considering introducing economic geography major, and they're pulling their alumni. So, oh no, it's to people currently enrolled in the school. So they do a simple random sample of 2,000 students currently enrolled, and of those, 532 have been returned. Of them, you can see the results. How can we generalize this? And remember, we are picking a sample to represent the entire population of interest. So we're basically trying to figure out what is the population? Where can we generalize this to? Now I can get rid of that. Did I ever stop sharing? I never stopped sharing, I'm sorry. So, oops, didn't want to do that. Oh my gosh, sorry, this is going haywire. All right, let's try this again. So 2,000 who received the questionnaire. No, we can generalize more than that. The 532 who responded. No, I mean, we're talking about where can we generalize this to? So we could go even more than that. The 219 students who support it. No, I mean, no one said that, so that's good. The 2,000 students selected represent a sample of the population of all currently enrolled students. All students who are currently enrolled and all past alumni of the university. So notice, since it's only for the current student body, the alumni don't really matter here. So we're going to generalize because, again, it's only students currently enrolled who were sampled. So that was their population of interest. So this represents the current population of students. All right. So D is the answer for that one. There was another question here. We could probably do this one pretty quickly. I'll just leave this up for a second. And just to make it easier, you guys can circle on the screen, anyone who's feeling brave, what you think the answer is. So it looks like most people are thinking this is a convenience sample, and that is correct. Okay, so in this case, the company is trying to figure out what the market thinks about a new product. The market represents all people, even not their current customers. So if they only use their current customer database, that's like picking a low-hanging fruit. They already have that information. They don't have to do much work. Now that can give you some information, but it's not gonna, people who are your customers already probably like your products. So you want to find out people who haven't bought from you before. Anyways, you get the idea. That is a convenience sample and not how you want to approach this. So we're going to be talking about half of chapter 13 today. And the rest of class is actually going to be just some practice. I'm going to let you guys, well, we'll get to that in a minute, because there's not a whole lot to talk about for content today. Now, some of this housekeeping might or might not apply. Sign up for the AP Classroom if you haven't yet, but I believe everyone has. If you have not done the AP contract for your plan or the progress checks, make sure you're taking care of that. So anyways, if you need to make a note to yourself to do any of those things, if you haven't done it yet, just please make sure you're doing that. Again, I want to reemphasize the progress checks. I believe I assigned the newest progress checks for you, which is for Unit 3, which is what we're currently, that's AP Unit 3. So that's going to correspond with this content that we're doing in class right now. So if you want to see what AP questions look like, I recommend going to AP Classroom and kind of starting to look through it. You don't need to answer them right away. If you just want to see the progress check and then come back to it later, you can do that. Okay, observational studies is the first half of chapter 13. So experiments, that's the big one. But we also have another thing going on, which is called an observational study. I hope you read, but we'll make sense of this one way or the other. So one of the most important properties of experiments is that subjects are randomly assigned. And we're going to talk about that more tomorrow. But in observational studies, the data is collected from subjects that are not randomly assigned. That's maybe the biggest difference between the two. So and we're going to talk about why you do an observational study or an experiment. But people self-select. Are they going to do an hour of exercise every day, or are they going to do no exercise every day or something in between? And that's what people select for themselves. And so if that's the case, if we're looking at a group of people who exercise an hour a day, we can compare those to people who don't. And we can observe the outcomes. So here's an example, and you might have remembered this. This caused a little bit of an interesting situation last summer. But in July 2020, the Henry Ford Health System released a study that showed that hydroxychloroquine reduced the death rate of COVID-19 by half. The study looked at patients treated at a clinic over the course of 2 months who were not randomly assigned the treatment. So it was not an experiment, it was an observational study. All right, so far so good, I hope. Observational studies come in two flavors. We got the retrospective one, looks at events that have already happened in the past, and so we're collecting that data. And the hydroxychloroquine study was a retrospective study. So it looked at outcomes from past patients, but we also have prospective studies that follow people into the future to see how certain factors can affect a response variable. And so you might have heard about researchers who watch kids as they grow up and they observe them. And of course it would be, and we'll talk about this in a minute, it'd be highly unethical to randomly assign a kid to be raised a certain way. So you wouldn't do an experiment on young children, but you could observe them and you could kind of look at certain factors and see how that changed, like a baby born with fetal alcohol syndrome versus those who were not. All right, okay, that's kind of in the way here, but neither type of study has any controls for other variables or confounding factors. So we'll get into that stuff. Again, that'll be more tomorrow. So observational studies of any type are subject to a number of factors that limit their usefulness. So they're both subject to confounding variables. All right, we talked about confounding variables, or did we call them lurking variables in the past? But whatever the case, there could be other things going on that we're not controlling for when we're looking at a study. We can never use an observational study to say that there's a causal relationship between any two variables. There can be an association between the two, but we can't say that something causes something else to happen. So in the hydroxychloroquine study, some patients given the treatment were also given steroids. So it can't be confirmed whether the decreased death rate was from the hydroxychloroquine, the steroids, or some other factor. So that wasn't controlled for. And both of these are subject to flaws in the data. And if it's past data, it might not have been recorded accurately, especially if you're going into the past. Like some people look at how death rates have changed over time, but if you're getting back, especially back into the 1800s, how reliable are those health records? That's debatable. So death might have been caused by other factors than what was recorded. So that's just something to keep in mind. And that could be true today. Maybe it's labeled as like heart disease that was a problem, but maybe there was something else that went on that actually caused the heart disease to onset. All right, in spite of their limitations, sometimes observational studies are the only reasonable option. So let's see why. Some types of experiments have too many factors to reasonably be able to control. And that means, and we're gonna, again, I keep saying tomorrow we're gonna look at, is it tomorrow? Yeah, tomorrow we're gonna look at experiments. But we wanna try and control everything, and there are ways of doing it, but if there are too many variables that it's just really hard to control it, then maybe an experiment is just too hard to try and do successfully. So if you're investigating the effects of socioeconomic status, you can't randomly assign someone to be high and low economic status. So if you're trying to control other factors associated with that, it would be just about impossible. Some types of experiments are unethical. So this actually, you might have heard of the Tuskegee syphilis studies that went on for many, many years. where they allowed, I think it was all Black men. They were doing experiments basically on Black men that allowed them to, people with syphilis, to not get treatment for it because they wanted to see kind of the effects. And I don't know exactly what it was they were looking at in this study, but it's something that these days would never be allowed. It's highly unethical. If you withhold cures from people just so you can research what would happen or things like that, and you can see right here, I mean, it could be criminal, you know. So obviously you don't do stuff like that. But if someone has a disease and you're trying to cure it, but you can also observe what happens, that's not unethical at all. That's good. That's good to gather some data. All right, so I'll leave this up here for a second. That was kind of it. Maybe I'll go back one real quick. So just some conceptual stuff about observational studies. So just be aware of those ideas and read the chapter about it. And I highly encourage you to read about experiments ahead of time. So tomorrow when we go through it, you're feeling good about it. So the next part of class, I just have a few, I think it's like 8 problems, and I'm just gonna let you look at it and circle what you think is the best answer, and then we'll talk about these, and that's really all class is today. So it's not gonna take as long, hopefully. So we've got pretty much everyone answering the same thing, and I like to see that, especially when everyone answers the correct answer. That's the best. And this is correct. So it is important to remember that stem and leaf plot is a quantitative data display only. And of course, I'm not gonna do too much here, but you might have, you know, your numbers coming off to the side. That'll be your leaves coming off the stems. Everything else about this is not true, but the great thing about stem plots is that it does still show the histogram of the data, which includes gaps, clusters, outliers, all that fun stuff. The bad thing about them is that if you have too many data points, it's just not a very useful data display. So you don't want to use it for very large. I'm not going to read through all the reasons why this doesn't work, but yeah, good job on that one. So let me clear this and we'll look at another question. So everyone right here is looking at this and deciding that A is the correct answer. We've got the regression line. So we're dealing definitely with scatter plots and things like that. And since we're asked to interpret the slope, we're looking at this right here. The deaths is in thousands. So, I mean, A is correct. I'm not going to read through all of those, but some of these are talking about the R squared, the coefficient of determination. That's what these two are talking about. One of them is correct, but it's not asking us to interpret the R squared. This is referring to the y-intercept, and this is referring to extrapolation, which is a bad idea. We can't extrapolate this data. All right, very good. All right, another problem right here. All right, let's look at this one. And maybe these kinds of questions I know are the ones that can drive me insane, and maybe they drive you insane too, where you look and you're like, I'm convinced of one of these, and one of these I'm not sure about, so now I'm not sure what the answer should be. Anyways, given 2 points from a scatter plot, when you have a negative correlation, what's possible? I'm going to draw a negative correlation on here. Here's my regression line. Here's a bunch of data points. I can pick any 2 points out of this. So the first point has a larger X value and smaller Y value. So if I pick, let me get a different color now. If I pick that point and that point, if this is my first one right here, I put a double circle around the first one. That one has a larger X value and smaller Y value. So that is possible. Yes. Let's skip to number 3. The first point has a smaller X value and a larger Y value. So the first point, maybe now this one is my first point. So that one has a smaller X value and a larger Y value than the second point. Okay, we're still good. So that one's possible also. So 1 and 3 are both possible. The question is 2 possible? the first point has a larger x value and a larger y value than the second point. So now I'm going to pick this point and this point. And this one right here is going to be my first one. So this one has a larger x value and a larger y value than the second. So that one's possible too. The answer is all three of these situations are possible. Remember, a scatter plot, a regression line is just a trend line, but it's not saying that every point is going to follow that trend. You can definitely have 2 points that buck the trend. So this would be basically a positive slope between these two, and that would be a negative slope between those two. But anything is possible in a scatter plot. Okay, so this time our consensus failed us, but that's okay. We learn. That's not what I wanted to do. Sorry. Okay, so let's move ahead to the next problem. All right, just a few more. So stem plots again, but this is good. The reason I put this question in here is because we haven't talked a lot about back-to-back stem plots, so it's good to see those. And this has the same stem, but we got 2 data sets, A and B, and so we could think of this. Now it doesn't give us a key, so that kind of violates one of the rules, but that would be 127. This one right here would be 125. And then of course we'd also have 121 over here, but I'm not going to go through any more of that. So when we're comparing the 2 distributions here, we can see that one of them is approximately normal. One of them is definitely skewed. So this answer C that was given is correct. None of the other ones apply here. I'm not going to go through all of them, but definitely the mean for this one is going to be lower than the median. And lower is that direction. But the mean and the median should both be about here for that one. All right, the only other one I wanted to talk about real quick is this answer right here, because we haven't talked much about variance. So variance is just your standard deviation squared. And we might have talked about it a little, actually don't remember if we did. This is going to be something that we come back to later. And it is a specific thing. So variance is not the same as variation, and they're not interchangeable. So the variance does change depending on the shape of the distribution. So these variances will not be approximately the same, because this skewed one right here is going to throw out the variance. Anyways, just wanted to mention that little bit about variance. You shouldn't obsess over that too much right now. Just wanted to point it out. All right. So here we go. I think we only have like 3 more after this, so, or including this one. So there you go. Hopefully everyone had enough time to kind of reason through it and think through it. But everyone here is saying simple random sample. So simple random is you have all of the, now she's saying 47 business cards, 47 cards, taken the entire sample frame, and you randomly pick, in this case, 5 from it. And the question you need to ask yourself if it's simple random is, does every group of 5 have the same probability of being drawn? Because imagine you could do an infinite number of drawings to get 5. I don't know why you would, but does every one have the same, every group of 5 have the same probability? In this case, yes, this is simple random. So you're good to go. That is correct. Okay. I think the next one, yes, this one got a little blurry. Hopefully you can read it, but try and work your way through that one. So what's going on here is, of course, the columnist just asked anyone to respond how they would, if they would marry their spouse again, and 25,000 responded. They were not randomly selected, and this is kind of debatable on what the correct answer is. I will tell you the best answer is A. It is voluntary response, and so it's kind of debatable on maybe how you kind of think through it. though I do think that's really the only good answer. But if she had picked, what's confusing about C, and I can see why people picked it, is because if she had picked 25,000 people to sample to begin with, that could have been legitimate. And then she could have generalized that to only her readers, not to the entire population, but to her readers. But what it says is pick a random sample of those who responded. So we already have the voluntary response. So that actually doesn't fix the problem. So this is only people who voluntarily responded. So of the 25,000, these are probably 25,000 who have very strong feelings about not wanting to marry their spouse if they could do it again. A lot of people probably were totally content. So anyways, I'm not going to read through everything else, but A is the best answer here. Now, if you had kind of combined a few answers, E says it's a legitimate sample randomly drawn from her readers and sufficient to allow the conclusion that most of her readers who are married would have second thoughts. So this is what I like about this one, is that it does show you that the population, most of her readers who are married would have second thoughts about marrying their current spouse. So that's where you can generalize it to, but it's still not a random sample, so it's kind of broken. All right, I believe this next one is our last one. Okay, so the good news, we got a lot of people that kind of consolidated around that answer. The bad news is, unfortunately, it's the wrong answer. But that's okay, we're going to talk about this. So it's better to get a wrong answer right here than it is to get it on the test, right? So that's the key thing, and hopefully this really helps to drive the point home, is that in a simple random sample, and we're trying to figure out, is this going to result in a simple random sample? Is that going to happen with this method that we picked? And a simple random sample means that every possible, I'm going to do a very simple scenario. I'm going to have these 9 dots right here, and I'm going to randomly sample 3 of them. All right, so any 3 selections is applicable. 1, 2, 3. All right, that's good. Maybe I could do 1, 2, 3. All right, that also works. 1, 2, 3. That's also fair. I'll just do one more. 1, 2, 3. Okay, sorry. Let me erase one of those because now I had 4. All right, so that also works. Every single sample of 3 has an equal probability of being selected. Now I'm going to split it up a different way. Oops, I got rid of the dots. How did that happen? How did I get rid of the, I don't know how I got rid of the dot without getting rid of the circle. But anyways, now in this case, these are going to represent baseball teams. And now I'm going to randomly sample 1 from each team. So 1, 2, and 3. All right. Now, no matter what, I had to have 1 from each team. I know that's not what the scenario said, but I'm simplifying it. Now, what can never happen is this right here. I can never get 3 players from one team to be randomly drawn, because that's not how this is set up. So hopefully you're kind of following along with the logic here. I can get a lot of different 60 player samples, but I can never get more than 2 players from one team. So I will never have a sample that has 30 players drawn from one team, but in a simple random sample, I would. So the answer is E. Not every group of 60 players has the same chance of being selected, so it is not a simple random sample. A stratified sample is actually different. It's not a special case of simple random sampling. It's a different kind of sampling. All right, so does that clarify a little bit? Help it make sense? Anyone have questions on that, I should say? Okay, I believe if you still have questions, we can come back to this. I believe that's it. Oh, I lied. There's one more important question. This one is definitely the last one. So try and answer that one real quick. So this is the thing right here. Notice it's called sampling error. And this, another way of talking about this is sampling variation. And remember, this is kind of the last key thing we talked about in our class yesterday, is that sampling variation, sampling error is a natural thing that cannot be avoided and will always happen. Well, that's not necessarily true to say it will always happen, but but anyways, the answer here, this is kind of a tricky one. The answer is actually D. Anytime we use a sample statistic to try and make some kind of inference about the population, we're probably not going to be 100% right. And there's going to be some kind of a difference between what our sample says and what the true reality is. That is sampling error. It is a natural thing. It's to be expected. It is not a mistake. And we don't get, now, this is kind of where it's a little bit tricky. Maybe you were thinking through that. But when you have bias and you're not using random samples, or you're not sampling enough people, that does result in your statistic being off, but sampling error doesn't occur because of that. Sampling error is just a natural thing. We're assuming that everything's going correctly, and it's still not 100% accurate as far as predicting what the population thinks. All right, so again, hopefully that makes sense. I guess the main takeaway is just keep in mind sampling variation is natural, not a problem. And we have different ways we can talk about that we're going to get into more in future units. So I'm going to go ahead and clear this up. If you have more questions about any of the stuff that we talked about in class, then certainly stick around and let's try and get that clarification. But your homework is, we already started chapter 13 with the observational studies. The experiments takes a little bit more. So read that. And the unit 2 is currently available. I actually don't have any new homework for you. That's kind of nice. So just tonight, if you are trying to get caught up, you have some time to do any old homeworks. The old progress checks get started on the new progress check, all that fun stuff. So with that, if you are satisfied with your care, have a wonderful day. I will see you tomorrow.